Okay.
Go back to seconds though. Yeah, of course. We can do anything. So, I got it. Nah, you're not yeah, you look like a yeah. You look like a shield. Yeah, you look like
Okay. Good morning, folks. Any other acid-base labs you could bring up and just put on the pile here? That'd be great. Good morning. All right. You got Oscar. That's good. And this thing. All right. Okay. So it just might work if I get this thing turned on. It is on. Okay. And it's not on. Okay, let me try it again. I hate all this really. Okay, we see something, right? Come on, thing. here. That is here. Source. Okay, do I have any tech savvy folks who could help me do this? Because I don't remember which way this thing goes. I gotta get this here there. And this looks like somebody took it out, so let me try and put it back in. Love it. That's what somebody do that. Good. Yes? Is that gonna do it? Theoretically? If I keep this thing in here? Well, your other teachers struggle with this crap as much as I do. Pretty much. Everybody is different, that's my problem. Okay, good. So, anybody else there? I got Bella there too, so morning Bella and Oscar. Morning everybody else. My lab people too. So, any other acid base properties of labs, just put up here in the pile. I can grade those actual assignment. As promised, I will go over the multiple choice questions now with you from the quiz that I hope most of you, or I hope all of you are able to do. I'll assign a essay quiz this week, and I'll just make it one question, probably 20 minutes. And so please find the time by Friday. Please don't make me do this crap again. I'm pretty pissed at you for doing this. Okay, I want 20 minutes of your time between now and Friday. Do you really want me to sign it till Friday at midnight? You realize why I didn't do that? I wrote it clearly in instructions Friday at 6 p.m. So I thought, okay, you'll have a nice weekend. I don't need you up till midnight on a Friday doing AP Chem. When do you want the deadline for this? You tell me. Tell me. When do you want it? And Sophie? When? Friday?
Yeah.
Friday, 9 or 10 at night. All right. I'll do that. But honestly, I don't like doing this to my students. I don't want you working on Friday night particularly, but I want you relaxing after a hard week. All right. Okay. Then I'll do that this week. And again, it won't take a lot of your time, so please do it. I'll tell you clearly today what it's on and so on in an email. Okay, so let's see how we did on these, all right? I haven't looked at your grades at all, but let's look at the questions and see if we can figure it out. Okay, so question 1. Okay, so let's see. Can Oscar see that too? The answer is no. Okay, now I think they can see it as well. Okay, so they give you an equation, and the value is 14.5 for the equilibrium constant. And let's go. So I got a mole of this stuff, of CO, and a mole of H2 are pumped into the originally evacuated 2-liter vessel. Which of the following is true? So we got just some of that and some of that. Importantly, they have how much product at the beginning? How much product do they have at the beginning? Read what they tell you here. 0. So it's important you have to understand that. If they give you only reactants, that means there's no product there. Which way is this reaction going to go if its K is that big anyway? Towards the products, right? Because it's way bigger than 1. Okay, so already we know it's going to run forward. Okay, so let's see what we got as possibilities at equilibrium. Okay, that H2 would equal twice the CO. All right, let's think about that. We got a mole of each. And they're reacting in a 2-to-1 ratio. And we're using more of which chemical? Which chemical are we using more of to make the product? The loud. H2, thank you, right. Yeah, so we're making more of that. So does this make sense then? No, right? Because we're gonna have less of that. It's not gonna be twice the other. We're gonna have less H2. So I don't like that choice. Okay, let's look at this. Next one. The H2 concentration will be less than CO. Well, that's a possibility. Let's see what else we got for answers. I forget which screen I'm working on. Okay, CO, that's one of the reactants. The CO is equal to the amount of CH3OH. Given that your equilibrium constant is 14.5, are these two going to be equal? Probably not, right? Because, I mean, it's going to really go towards the products with 14.5. That's a pretty big number, way bigger than 1. Whether it's less than H2 or not doesn't really matter, but I think C and D are thrown out of there. So the answer is going to be B. Yeah, so it's going to be B. Yeah, it's the only one that makes sense that the H2 is less than CO because I'm taking 2 H2s for every 1 CO. So there's got to be less H2 left. It's being used up twice as much. Let's look at the next one. The next one, okay, so we got 2 reactions. Make sure you guys are watching there. I got 2 reactions, and the equilibrium constants are 10, and look at this is a big contrast. So really going towards products and hardly happening at all. And it's again a 1-liter container. I got 0.5 moles of the appropriate reactants. And after the reaction was allowed to reach equilibrium. Based on the information, which of the following correctly compares the relative concentrations of BRCL, that stuff, and NO. Well, what would you guess? What are you going to get more of? BRCL or NO, and why? What are you going to get more of and why? Anthony? Yeah, okay. So let's kind of look for that in our choices down here. Let's see. This one's got an equal. This one's got the answer that Anthony said, and so does this one. So it looks like it might be between B and C, huh? Let's see what they say. So B, B more than NO because BR2 and CO2 are larger molecules that can collide more frequently to form products. And BRCL more than NO because of the much larger K value for the reaction 1. The one Anthony described was which one? His answer. C. So it's looking like C for number 2. Yeah, and it is indeed. Oscar or Bell, if you got a question, type it in, please. Okay, the next one here, multiple choice. A lot of information on this one. The K is really small. That's a good thing to know. Okay, we got 100 torr of HI. Remember, torr is the same as what other label? What's a torr, Lori? Millimeters of mercury. Thanks, Lola. Yeah, so just another pressure unit. Okay, 100 torr of HI is added to this container. It's allowed to reach equilibrium. The partial pressure of I2 is then 3.7 torr. That's not much. If the initial pressure of HI is increased to 200 and the process is repeated at the same temperature, which the following correctly predicts the pressure of I2 and Y. Okay, let's have a look here. Okay, so it's 14 instead of 3.7 because it's directly proportional to the square of the initial pressure of HI. Okay. It's 0.073 because it's an inverse proportion to the square of HI. Okay, it's 7.4 because it's directly proportional to the initial pressure of HI, and it's 1.9 because it's inversely proportional to the initial pressure of HI. Okay, let's just think about it for a sec. Okay, if I increase this to 200 bar instead of 100, are we going to get more or less I2? More. So we could throw out what already? We could throw out B. I don't think that's happening. What other observations we got? Yeah. Nina. That's really loud. Yeah. That's going to be it, Amina. She says she's multiplied 3.7 by 2 because instead of 100, 200. And I think that's the easiest way to do it. I think there's a direct relation there. In spite of the fact that there's a square here, it's like, how can I say this? I mean, I think you're right because I think we increase everything, so to speak. So I think it's going to be in the same ratio because we got the same equilibrium constant. If that really is a constant, then if I increase this, then these two are going to have to increase at the top proportionately. So I think it's got to be what she did. Just double 3.7, and it's going to be C here, 7.4 torr. Because it's directly proportional to the initial pressure of HI. Yeah. That I find to be the toughest one, to be honest, because it requires a lot of thinking. Ask me if you got questions. I know it's early in the morning, but see if you got anything as we go through that you want to ask about. Okay, I got this big long reaction. Equal numbers of HCl and O2 in a closed system allowed to reach equilibrium as represented by the equation above. What's true at equilibrium? Okay, I got HCl and O2 in a closed system. How much product do I have? Don't make this hard. I need everybody to be able to see this. Come on. I got moles of HCl and O2. That's all they tell you. How much product do I have? None. None. You guys have to be able to do that quickly on a multiple choice question. If they don't tell you you have any product, you have none. Okay? Sorry to get on you, but you got to be able to see that. Okay, let's look at these things. Okay, when it reaches equilibrium, what's true? HCl, this stuff, must be less than CO2. Well, the problem with number one is they don't give us a what for this reaction. What do they not give us to help us? They don't give us the equilibrium constant, exactly, Chelsea. So I don't really know if HCl is going to be less than this or not. Okay, let's look at this one. O2 must be greater than HCl. There's O2, HCl. Aha, well, I do know I got a 1 to 4 ratio, so I'm using 4 HCl's for every 1 O2. What do you think about this number 2? Somebody comment on that. Amino, what do you think? Yeah, okay. Let's look at the third one. The Cl2 must equal the H2O. Well, I don't know anything about the equilibrium constant, but what do you notice in the reaction? CO2 must equal H2O. Answer B. A little louder, please. Good. That's important. 2-to-2 ratio. So let's look at our choices down here. So 1 we didn't really like. So it's looking like, which one?
D.
Probably D. Yeah, I think that's the one. Or this one. Yep. Okay, and now we've got this reaction. A pure sample of CO5 is placed in a rigid container of 1 liter. My people, a pure sample of P5, how much product is there? 0. Thank you. So, the initial pressure is 1 for the PCl5. Okay, the figures below show the initial and equilibrium conditions of the system. Okay, so 1.4, 1.4. Here's a question for you. Just roughly thinking. Remember, equilibrium is what? Products over the reactants. And here, my total pressure is 1. Okay, all I got is this thing down here. Here, my total pressure is 1.4. And notice this is 1 mole going to 2 moles, right? What if my equilibrium constant was really high here? How much pressure should I have? Let's say it was like 100,000 for KEQ. If I started with 1 atmosphere, how many atmospheres should I end up about at equilibrium if the K was like 100,000? One of these makes one of these and one of these. And if I start with 1 atmosphere of this entity, like 2, well, it's all about atmospheres.
Right.
No, the equilibrium constant. I said, what if that's 100,000? What would be the pressure then? Instead of 1 atmosphere, it would be 2, because it's pretty much going to products, right? But look at it, it's 1.4. See what I'm saying? So it's probably not that big of a K. But on the other hand, it's not 1, is it? In other words, it's not doing nothing. It's not an equilibrium constant that's like 1 times 10 to the negative 14th or something silly like that. It's doing at least a little bit. Okay, now let's go to our question here. Okay, additional CO2 is injected into the system. Where's the CO2? Well, it's a product. Which of the following shows the rate of reverse reaction as a function of time? Okay, now, that's really important. The reverse reaction. Reverse reaction. Let's go up and look at what that would be. So the reverse would be the products going back to make PCl5. Okay. So assume you got some of this happening in the vessel, some are going backwards. Now I'm going to pump in some Cl2. What's going to happen? Arrow. The rate will increase. Okay, so. And we did a lot of these with Cheryl in the book. Let's take a look at what could happen. Okay, so here's one where the rate increases. But oddly enough, the reverse rate, they show it being like 0 up until that point. So this one seems kind of weird. Here's one where they inject the Cl2 right there, the rate increases. Here's another one where it increases. And there's another one where it increases in kind of a way. Well, what did you learn from Cheryl? Once it increases, what happens to the graph, so to speak? What happens, Anthony?
Going down again.
It's going to go down a little bit again. Will it go all the way down to where it started? No. Good. Okay, so which graph is that, gang? B. It's looking like B. Boom, and then it goes down, but not to where it began. So I'm going to guess it's B, and you are right. It is B. Okay. We had this one in class. So these guys making 2HI. The gases reach equilibrium, which describes what will happen to the reaction immediately after additional iodine gas is added. So now we're adding I2. And what's going to happen initially if I add some I2? Bola.
Will the forward reaction become greater?
Yeah, good. So we're going to bunch this one. This sucker's going to move more forward, make HI more for a bit. Let's see what they say. The rates of both forward and reverse reactions decrease. The rates of both the forward and reverse reactions don't change. The rate of the forward reaction becomes greater than the rate of the reverse. The rate of the forward reaction becomes less than the reverse. Okay, which one is it? Okay, it is indeed C for that one. Okay, now, I'm not up here to try and claim these are easy or whatever, but I just wanted to go through them and get you thinking about the way that I think of these things, okay? You really got to look at specific words like reverse reaction, and this is given, meaning I don't have any products given, and let your mind grab onto those facts and think about what they mean. Or if I have a really big K or a really small one, what that means. How did you do on this one? I haven't looked at any of your results yet. The time was a factor. Okay. A lot of you are nodding your heads. Yeah, I quite agree. I didn't choose any to be especially long or short. I chose them fairly randomly. But the time in the AP is 1.5 minutes per question. So I gave you even a little more time than they would. When you have a lot of them, the strategy that I recommend, and so does the AP, is try and go and do the easy ones first, and then come back and do the ones that take more time. That may vary per person, what you think is easy and what the next one does, but you may want to do that strategy next time, even with 6 of them, just to kind of get ready for that. Look through if there's anything, oh, I think I could do that one fairly quickly anyway, and then bump, get rid of it, and go back and do the other one. Certainly when you have 50 or 60, I got to look at the format this year, unless you already did, on the actual AP, then you want to use that philosophy. One time through, then go back and do all the other ones that are harder, that take more time. Noah.
I found it that the wording of the problem is sometimes confusing, just because like doing it in class is like really simple and I can understand it because you're explaining it, whereas I'm doing it like on my own. I'm trying to like read there and the wording and just like how you have to think about the answers. It just confuses me sometimes.
Yep. Yeah, the wording can be confusing. I know you have a limited amount of time, but quite often what you got to do is read it 2 or 3 times. I find that if I read it once, unless it's a really easy one, it's not enough, and I got to go back and read it again. And really, I circle things, I think, whatever it takes for you to get the ideas moving in your head as to what they're asking about. Because I know some of these, they give you so many numbers and diagrams and stuff, but it's pretty intimidating in like 2 minutes. Your brain's got to go really quick. And remember, they're not expecting you to get 100% here either, folks. So you you want to guess on every one, just like on the actual AP? There's no penalty for guessing for me or the AP test. But some, yeah, if you run out of time, you run out of time. Just put a letter down. Other questions, comments from you? So why am I torturing you? Why am I torturing you with these every week? Because I'm just yeah, I want you ready for both the real AP test if you're taking it, and certainly for my clausura as well. Okay? And other AP tests too, to be honest. These scores are going to be just the number of points that I have. So it'll be like part of your homework grade, but I'm grading them at an AP level. So when I give you your grades, what I've kind of decided to do on these folks is I'm going to give you half the points just for doing it. So for like this one, I have it worth 12 points. So I'm going to give you for 6 if you just got on there and did the thing. And then depending on how well you did on the AP scale on the 6 problems, you know, if I got 5 or 6 right, I'm going to give you all the points. I'm going to give you 12 out of 12, so to speak. Okay, so I'm not grading it fairly, I'm grading it in an easier way because it's hard AP test material. And I'll grade it as such. Okay? And if you're in there swinging, even if you don't get any right, I'm going to give you half the points, okay? Good. Other questions, comments from you about multiple choice and stuff like that? Aiden?
In math class, you said you're going to talk to Mr. Blessman about like the AP test dates and stuff like that.
Thank you for reminding me. Yeah, I talked to Mr. Blessman and I said, what do you think's going on with this? Or what should I tell students? And as far as we know, we both agreed on this, that if you signed up even for the earliest date in May and you don't feel prepared to take it, don't show up. And then you'll be considered sick and you have to then take the retake. I don't think you need a doctor's excuse because it's for the AP test. It's not an official school period absence. You know what I'm saying? Yeah. If they give you slack on that, send them to me. So I'm saying this carefully, but I want you to do good on it. If you're ready the first part of May or whenever you signed up for it, do it. Okay? But if you're not ready, don't show up and take the makeup whenever that is. Is that the one later in May or is that the June one? The later in May one. Okay, so later in May date. Let's see. Oh, and I missed your question, Bella. I'm sorry. Yeah, there's no product if they only give you reactants. So maybe ask me in an email and I can answer it better for you. I'm sorry I missed that. Alex. Okay. So that's kind of the latest word, Aiden, talking to Mr. Blessman about that. All right. So in spite of the fact that your group was told you need to like do everything the same way, I feel like when it comes to that test date, you need to be individuals. If you're ready, take it. If you're not ready and you want to reschedule it for the makeup time, don't be there. Oh, I think the makeup test, I want to say it has 2 options. Does anybody know that for sure? They sent me so much information, I forgot. I think the one in June is all digital. And I think it's not even the same length as the other 2. Yeah. But the makeup one, I'll try and find that out, Chelsea. And Sophie? Right, well, Ms. Hale kind of told you to choose as a class, right? No?
The school, the scheduler and the school, they decided that we need all of them in person.
Right.
And then anything like, we have with all like the new dates and times for each test.
So you still could do it individually, in terms of which day you pick.
No, there's only one date. And we weren't even allowed to have a say in it. So the school just decided to do it, like they had a decision between sending us home and letting us doing it at home online
Right.
or here in class.
Yeah.
So,
Well, like I said, here's the bottom line. What the school has to do is this. If any student is sick or unavailable on that day, just say you're sick, they have to have a makeup date available for that student. You know what I'm saying? So if you don't do it, then there's a makeup date that will be available for you, and of course it's later. And I think it's the May one, but I'll have to check and make sure it's later. So it comes down to you individually, as it needs to be, in my opinion. What's it?
I don't get we wanted to go well we still online. I think we can get part.
Check the this Shepherd. Just
I
quickly.
have not I can show you.
Okay. Just send it to her. We should put it on the class chat. That'd be great. Okay. Good. Other questions, comments from you about things in general, community?
Did you say the online one was shorter?
I think the one in June is a bit shorter. Yeah.
They are, but that's right. Because I got this exactly the same way.
The one on June, I think is short. I gotta look up what they told me again, but I was a little surprised by it. You know? I'm not going to more questions. No, they're not going to do that to you. It wasn't the same time and more questions. Let me look up the format. They've sent me enough emails over the last few months, but I don't have it memorized what they said. So let me write down the 3 dates. Here, I'll make myself a note. AP test, dates, and formats, which is makeup. Okay, so that'll be my homework for part of today. Anything else? Questions, comments from you? Yeah, Alex?
A question not related to the AP test.
Yeah.
What's happening with the books today? Are you
The books, during our quick break, I'll grade as many as I can. So those that I didn't get your chapter 1 in book 2 graded yet, just put your book here during break and I'll try to do a few. Okay? All right. Good. And I think we're done with this. That'd be great. That'd be great. Okay, let's then get out of here. And I think it's done today. Let me guess, the batteries are dead. I love it, Jay. Yes. Hey, all right. Boom, 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 boom. Bella is on the stick. You ready? Here she's what she found. The first 2 exams are on paper in the school. The last one on June 10th is digital and will contain more multiple choice and less frequent response questions. So you're both right. Okay. Thank you, Bella, so much. So everybody got that? So the digital one, more multiple choice, less FRQ. She writes the digital exam will also not include questions where a calculator can help you. Will not include questions where a calculator can help you. So it doesn't matter whether you got a calculator or not on that one. Okay, so it'll be probably a lot more mental math and so on. Thank you so much, Bella. For next week, I got to tell you about our schedule. We'll meet live on Monday here. And then we'll meet online on Wednesday and Thursday because I've got, if it's okay with you, because I don't have any of those femte componenten. So we're not in the school those days because they're doing their fifth components of the Abitur. But we can still have class. So Wednesday and Thursday, I'll plan on that with you next week. Okay, so it'll be online, our normal class times. And I'll just send you an invite for each of those. And Sophie. For our class. For our class. Next week. So right before Easter break, next week, Wednesday and Thursday, will be online classes for AP Chem. I don't know about all your classes. I'm just talking about my class. This week, Bella, is normal, as far as I know. So we'll be here. And for anyone at home, I will be trying to live stream each day, Wednesday and Thursday also. Good. Other questions from you to get our schedule straight? Okay, then, next order of business. Do you have any questions? Chapters 3, 4, 5. This is your opportunity to ask me some questions from your book. So, have you marked any pages? Are there any things you'd like to get some help on? By the way, last time you weren't here, but there's a copy you can leave some. Anybody else want a copy of the lab from last time if you weren't here? Okay, everybody else has it? Okay, good. Okay, so to you, any questions that we can work together on, strategize on 3, 4, 5? I realize you may not have started 5 yet, but you certainly can now. But 3 and 4, yeah, we got one here from Bella. So page 247, 1A. So turn to that page, everybody, 247. 1A. Good. Calculate the solubility of the following. And they wanted in moles per liter, which is the standard for solubility anyway. Okay, good. Give me the formula. Who haven't I talked to today? Penelope, what's the formula? Silver chloride? Thank you. And remember, for solubility, you do the same thing. Every time you start out with a solid, and then just sort of do what with it. Do what with it each time. Well, I'll go to aqueous. And what ions will I get? You know the other one.
Sorry, plus.
Minus. Well, you got to memorize those suckers. CO minus, you got to have that. Okay, so those are both aqueous. Okay, all right. So then, the K, I could say KEQ, but here they say the KSP for solubility product because I don't include the solid. So then it's just going to be, Alicia, what? Good. Then last thing is you can say, oh, they want the solubility. We can say that's S. So for every S of these, I get S of these and S of these. So the KSP is just going to equal to S squared. All right, everybody? And we've had some of this. So you got to be able to look up the KSP. Just think of it, Bella, as being a 1-to-1-to-1 ratio. How many of these dissolve? Well, if it's 1, then I get one of these and one of these. If it's an unknown amount, like in math class, we can say it's X and X and X. Or S and S and S. That's what we say in chem class. So then we just have to like take the square root of the KSP. And that number is silver chloride. It's 1.8 times 10 negative 10. And then that equals S. Whatever that happens to be. Good. Okay. We okay on that one? Other ones we'd like to ask about. Any others you've marked that you'd like to ask? Please feel free. Okay, while you're thinking, I'm going to pull this out. We'll take your question, Penelope, right after break. Okay. And for now, take a break. And if you got your book and I haven't looked at it, please set her up front. And I'll give a quick look over and give you points on it. Thank you, Alex. Put that right here. Thank you. Thank you very much. Good. Super. Thank you. Page 91. Page 91. Good. Page 83. Number 2. And 43. And 4.
No, I still can't. Oh, I got wait. But I have been about the spring, so.
You have to reapply that acceptance
why.
Page 91.
But I am finding that actually. I literally don't know. I have this huge.
You could replay the same book next to you.
I know. I
He's
have
doing
this
it.
so tired. Yeah, I mean, they're not gonna record higher. I'm so tired.
People thought there would be less after COVID and whatnot. That's optional.
I love the little hole in your mask for better ventilation. You might be finding that out.
Wait, you have something on your mask. No, it's in your mask. It's like a split. It's in your
I don't think you can wear those. Dude, I got my book 3 times and I had it graded dead weight. So if I write it this time, I'm gonna have it graded for
43. Good. Okay, so there's 2, go to there. There's 2. So we got 20, 30, page 42. Okay, got your books, Penelope, and I got Anthony and Aiden. Go ahead and grab your books. Here's yours, Aiden. Anthony, here's the bottom one. There you go. Anthony, there you go. Then who else gave me a book? I got no name and no name.
One of them is mine.
Okay, let's find out which one, and I can give you a grade.
That looks like mine.
That's yours. Okay, all right.
Yeah, I
So,
don't write in pencil.
okay, hold on. Can you put your names in your books, you two?
Oh, I put it on my other one. I must have forgot to put it on.
Yeah, put it on this one, because then
Yeah,
I can
because
do
we
it.
started
Okay.
it at home, so I forgot to put my name on it.
Alex, 28. I realize. So put your name in now. Thanks, Alex. And Louisa. Ta-da. And 20. Good. Put your name in and you're
Yes.
set. Thank you. Okay. Others, please bring your books on Wednesday so I can grade chapter 1. Thank you. And okay. All right, so we're gonna take one more question. Penelope, you're on.
Page 257, number
257, 1? Okay.
No.
Here we go. Calculate the molar solubility of blah, blah. Okay, so. Good, can somebody give me the formula? Sodium iodate. Sodium iodate. Alicia? It's a salt, so now it's a neutral. Yeah, okay. Molar solubility, so that's going to be S. Again, it's a similar problem to last time. Let's see what it's looking like. I think we just do the same darn thing like last time. So we do NaIO3 solid because we're thinking about how much dissolves. Na plus IO3 minus. And the KSP, you just multiply them together. I'm not asking you guys because I feel you can do that, right? I like to save a little more challenging problems for you. Okay, what's the molar solubility of this? If it's 0.12 molar sodium iodate. Let me make sure I'm answering the question right. I'm not answering the question right. Hold on. Calculate the molar solubility of silver iodate in my apologies, Penelope. I read it really sloppily, but it's still right. Okay. Calculate the molar solubility of silver iodate in 0.12 molar sodium iodate. So of silver iodate. So my only problem is I got the wrong cation in there, don't I? So I want the solubility of this stuff. So everybody, please change the Na to Ag due to your teacher's misreading. And then I think it's right. Okay? Now we can slow down a little bit. Just like last time, we could play the S game. So I don't know how much this is soluble, but for every S of these, we're going to get exactly 1 S of each. So S and S, good. Now, here's the only difference. We already got some, which other ion do we also have some of? According to the given data. We've already got more, what, Ag plus or IO3 minus? Aiden? IO3 minus, we got, because it's in sodium iodate. So what I got to do is I got to say plus this amount, 0.12. You know what I'm saying? I got some of both of those in there. That's how you do that. So the KSP, well, we can put the number now. So silver iodide, wherever the number is for that sucker. Silver, there it is. Silver iodate. 3.2 times 10 negative 8. Others do the same. Did I pull the right number? Does that look right? Okay, thank you. And then we got S times S plus 0.12 molar. Now's when I gotta slow down with you. This could be a really ugly quadratic, but what can I assume here to make life easy? Look how small this is. That is really big. So what can I assume? What can I do in this little term? Do you remember, Aiden?
You just leave the S out.
Yes. What I can do is say, okay, that's so small, the S is going to be tiny, like -4th or something, right? Well, in comparison, the 0.12 is way more important. So I can just say, put a mark here, and I'm going to write can ignore. Too small, so I can't ignore it. So that's the way, Penelope, to make it easier. Now it's not so hard as a problem to solve. So I got that it equals to S times 0.12 molar equals the same thing over here. But that's the trick. If one number is really big, you can drop the other number that is going to be really small, which is the S. So again, it's small compared to 0.12. Yeah, and then it's just whatever that is. S divided by this, 3.2 divided by 1.2 molar, whatever that is, in moles per liter. I'll let you finish that up. But that's the trick there. Is that okay, Penelope? Okay. Others who want to ask a question, Aiden?
That's supposed to say
0.12. Did I write it wrong?
That's on the denominator.
Thanks, Aiden. Good catch. Okay. Then, let's take the rest of our time and hit our next topic about acids and bases. It's essentially the start of chapter 6. So we'll at least, I think, get a good start on this today. So chapter 6 is about applications. Applications of acids and bases. And here is a serious glue. A buffer. This is going to be new material for most of you. If I can fit it in before you take the test in May, there's a short lab I'd like to do on buffers as well. We'll see if we can get it done. But for now, let's at least talk about doing one, and maybe we'll make one together. Let's do that. Let's make one together on Wednesday, first thing, a buffer. Buffers are really cool, and they're in a lot of stuff we take. Shampoos, medicines, stuff that we use in our body often has a buffer system in it. Our own blood has a buffer system in it. So it's in a lot of the human physiology chemistry. So what is it? What is a buffer? Someone have in their own words an idea what they think it might be? Have you had it maybe somewhere else? What is a buffer? Arrow.
It's in chemistry probably some sort of chemical that stops the reaction.
Yeah, in a way, it stops something from happening. Stops something happening. Just in a way, it stops it by neutralizing, so to speak. So to speak, we'll see exactly how. A buffer has an acid and a base both in it. Yeah, so let's put all that together. So it's a solution which contains amounts of both a weak acid and its conjugate base. Right, and Bellahead also, it's something that stands in the way of a reaction, so to speak. It stops a reaction from happening. Let's see what they have here. Well, my definition doesn't tell you much, does it? You should know they have a pH close to the pKa. Remember, that's the negative log of the Ka of the acid. But the big question is, we want to answer is, okay, so what? What good are they? What can I use buffers for? Buffers, like the one we'll make on Wednesday, are highly resistant buffers are highly resistant to changes in pH brought about by adding strong acid or strong base. I'll just write strong acid or base. So these suckers protect things from changing. So if I want to keep something at a certain pH like your blood or the medicine that you're taking, then I have a buffer in it to keep the pH from wildly going back and forth if somehow an amount of strong acid or base is added to the system. So it's to keep things buffered, to keep things gentle, to keep things in the same realm, as it were. Okay. Advertising in the US. Our shampoo is pH balanced. Advertising in Germany, it's pH neutral. Notice the use of German quotes? I'm proud of that. Never mind. Okay, so what does it mean? It means that they're balanced for whatever system. Now, your body differs. If I have a drug, it's got to be balanced, let's say, for your blood pH. If I have a skin product, ideally it should be balanced for the pH of your skin. Those are not the same pH. So you really got to know what buffer to use for different products. And manufacturers figure this out. Okay. Usually, I should write what that is. So, pH balanced, pH neutral means balancing the pH of the product to the pH of the system. Example, skin cream to skin pH. Pardon me, I meant to put that in there before I finished here. So pH balanced, pH neutral. It doesn't mean it's 7, by the way. I don't like the German advertisement. It always sounds like it's 7. It's not. It's whatever they're matching it to, your skin or your bloodstream or whatever it happens to be. Okay. Usually, people, companies, add equal parts of acid, or weak acid, conjugate base. For the weak acid, this drives me nuts today, sorry. For the weak acid, we're going to call this HB. For the conjugate base, we're going to call this B minus in sort of a general way, okay? So HB doesn't really exist. Let's just say B is any, anion. So they had equal parts of HB and B minus. So how do HB, B minus help? So now let's get down to the nitty gritty, okay? If HB and B minus make up the buffer, what do they actually do? Let's have a look. So let's say I've got some HB and I add a strong base. Add a strong base. Okay, so it means I'm really adding OH minus, right? What will I get? If I have HB and I add OH minus, what things will I get on the S products? Chelsea, go.
Water and B minus.
Yeah. Oh, sorry, not B off, B minus. Yeah. Think about those products. Water is pretty close to neutral. And B minus is not itself an acid or a base directly. It's not H plus or OH minus. So we've kind of eaten up this OH minus and we got it kind of out of the way, if you know what I mean. So we got rid of the OH minus. What if we add let's add a strong acid. Well, for that, then it's going to be the other part. Let's take the B minus, and essentially we're adding H plus, aren't we? And we just get what if that's the case? Well, what? HB. It just comes together and makes the, remember it's a weak acid, so it mainly stays together anyway. And if it's staying together, notice it in a way it kind of eats up the H plus, right? So either way, I eat up the strong stuff, H plus or OH minus, and get rid of it somehow on the other side. You got it. Thank you, Bella. That was right. Good. Let's talk weird but true buffer facts. Well, here's two things that are strange but true. One is you can always assume that equilibrium is established without appreciably, sort of means not very much, appreciably changing the original concentrations of HB or B minus. In other words, so the HB concentration pretty much equals the HB original concentration, and the B minus concentration pretty much equals the B minus original. So the O means original. You might say, well, how is that possible? Okay, we're going to find that out once we do a couple examples with buffers. But they just don't really change much, the original and the new HB, after I add something. Buffers don't work forever. In other words, I can't have a buffer and just keep adding more and more and more strong acid. Eventually, I overrun the buffer, and that'll be our next lab, okay? So there are limits to buffers. We're going to see what that is in our lab on making and testing buffers. You can still see that there. How are we doing? We're doing okay. After this course, be right with you, Anthony. After this course, you'll be able to look at the ingredients, like on the back of products. Just from what's in there, you're going to look and say, oh, that's probably the buffer. You're going to know if they're adding it and what that buffer is just by reading some of the ingredients. It's kind of cool. Anthony.
Are they stronger?
Yes. And it depends how much stuff you have of HB and B minus that you build the buffer with. And we're going to do exactly that, Anthony, in our lab, in our buffer lab. Ute. Okay, number two, the other weird fact is this. Since HB and B minus are in the same container, the ratio of their concentrations equals the ratio of their number of moles. This little fact ends up being really useful for you and I when we do problems. So because they're sitting in the same container, not only do they have this moles per liter and this moles per liter, but if they make it with equal number of moles per liter, for example, then they have equal number of moles as well because they're sitting in the same flask. Okie dokie. I want to give you three handy dandy buffer equations, okay? I think I want to use this because it's easier for them to see at home. Here we go. The handy dandy buffer equations are to get the amount of H plus, you take the Ka of the acid times a ratio of the concentration of Hb divided by B minus. Yeah, that's one. Another is I can go right to the pH. And to do that, I need the pKa plus the log of B minus over Hb. So these are really the same. It's just like the second one mathematically, they took the log of everything. And if it's, anyway, yeah, stop. That's enough. Okay, then the third one, I'm sure they can see all these things. The third one is this one, the H plus concentration equals the Ka again times N of Hb divided by N of B minus. Okay, remind me, what was N, folks? N is, 3 people know, N is the number of, Vinny? The number of moles. Thank you. So it's the moles of Hb divided by the moles of B minus. So if you think about it, these two are really the same. Okay? Really the same reaction. Good. Let's use them. Let's do an example in our time remaining. Good. Okay. Thanks, Oscar. A buffer is made by dissolving 1.00 moles of lactic acid Ka 1.4 times 10 to the negative fourth, and 1 mole of sodium lactate. To make 550 milliliters of solution. pH of the buffer. Find the pH of the buffer. It's often what we're most interested in chem anyway, is the pH of the pH of the system. Now you might notice I didn't even really give you the chemical, did I? You don't need it. Watch how I write it. Watch how I write it. I'm going to call this sodium lactate. You ready? I'm going to call this stuff Na-lac. This is quite often what chemists do. If something's long and complicated, just shorten it. And the other stuff can be H-lac. You know what I'm saying? So either I got an H plus attached to the lac, or I got a sodium attached to the lac. So I'm lacking a formula, but it doesn't matter. All right, which formula you want to use? Well, okay, let's go ahead and do it. So, and this time I'm going to change the formula a little bit, and I'm going to say it's going to be lac minus. You know what I mean? So if it's H-lac and Na-lac, then lac has a negative sign. You know what I mean? The rest of things like the negative part divided by H-lac. Okay, what was pKa again? What do I got to do with the Ka? I got to take, Louisa, the what? How do I get the P part? Just like for pH, I got to take the, who can help out? What do I got to do? Alex? The negative log. Yeah, negative log. So I'm going to take negative log of 1.4 times 10 to the negative 4 plus my people. Check this out. I want the lac minus concentration divided by the H-lac concentration. Look at the numbers. I got a mole and a mole. Penelope. Beautiful. It's just 1 to 1. Do I even need to bother to calculate those exact concentrations out? So just make your life easy. All over 1, or 1 over 1 if you want, so you know how you got there. Yeah, Penelope has it now. No, the negative only means kind of like this. Penelope, if I write my chemical like this, like a shorthand way of writing it, then it's H plus when it breaks up plus lac minus. So it's not in the formula, it's just like the ion is negative, that's all. Good, can everybody do that? Let's see what that is. What is log of 1, by the way? Punch that out. What is it? What is log of 1? Ah, you mean if it's 1 to 1, this is crosses right out? How cool is that? So all it is, it's the negative. If it's a 1 to 1 ratio for a buffer, It's just the negative log of the Ka. What do we get, answer fee? 3.9?
Yeah.
Others got the same?
Yeah.
Thank you. Not all buffers are 1-to-1, but most of them are. So you see how nice and pleasant that is? If it is, I don't even have to worry about the rest of this. Look at it, it drops out, it drops out, it drops out. And if I just want the H plus concentration, it's equal to the Ka. How cool is that? So the buffer equation's really nice, really nice. Um, Here's kind of a weird question. What if I dissolve that same amount of 1 mole and 1 mole in 5 liters or 10 liters? Will it affect the pH? No, that's not great. It does change something though. What will it change? Can you try and describe it? What will change? Penelope? Yes, the concentration of the buffer will change. How do you suppose, in terms of using that, it wouldn't matter if it's a lower concentration? Why might that matter if the concentration changes lower?
But we could assume that if the concentration is lower, then it's not going to work as well, and then it won't balance the pH.
Okay, it will have limits, won't it? It will have lower limits. If it's really diluted, it won't work as well. It won't work as long. But diluted buffers have a lower, and this would be our next lab, a lower buffer capacity. So buffer capacity is really, it's kind of how much acid and base can they absorb, okay? So it's the ability to absorb lots of strong acid or base. So it does affect that. It just doesn't affect the pH, which I find pretty interesting. Okay, let me pause, see if I got any questions. 3.85, Bill had the same thing. Good. Dynamite. Thanks for participating. I'm sorry I don't always see that, folks at home. Good. Okay. I'm going to give you a little pagey wagey here. See if she's got it somewhere. What's she do? She does titrations very good. Cheryl and I are doing it the same way. It's reassuring. I just got to get to her buffer page and mark it. There it is. Not. All right, then it must be in the last chapter. That's kind of annoying. I'm looking for some data that Cheryl has in her book, because I'd like to be able to give you that page now, so you're aware of where it is. You know what, though? I'm going to find that, and I'll have it for you next hour. Let's go on. I don't want to waste the time. Let's talk about how to choose a buffer. So, choosing a buffer. Choosing a buffer. What you do is you want the pH of your system to be about the same as the pKa of the buffer. So the H plus concentration should about equal, is it okay if I put squiggly lines? It means kind of about equal to Ka. So choose a buffer with a pKa close to pH 1. I'm going to do an example of that next time. 2. Usually, it's got equal moles of HB and B minus. However, if you want your buffer a little more acidic, add more acid, HB. More basic, add more B minus. How do you know how much? We're going to do that next time. I know I wrote a lot. I'll leave it there the last little bit while I try and find this page. Okay, Cheryl. Here they are. Oh, right there. Okay. Okay. Yeah, you could do that, Bella. That'd be fine. That'd be fine. Okay, I will save this. You two, bye for now. See you Wednesday.